Welcome back to Practical PyTorch. Last time you built the model with nn.Module. Now you learn how to feed it data. Meet the dataset and the DataLoader. Your model is ready. Real training rarely hands it the whole dataset at once. It feeds one batch at a time, and the order is shuffled each pass. Two classes do this. A dataset answers two questions. How many items, and give me item I. A DataLoader wraps it and hands out shuffled batches. Stacking a batch is where the batch dimension B comes from. This video has 4 parts. First, the dataset. It is just 2 methods. Second, the DataLoader. It shuffles, collects, and iterates. Third, the batch dimension B. 4 items become one tensor. And fourth, the last batch. What happens when it does not divide evenly? First, the dataset. The 2 methods that say what your data is. Subclass dataset and write 2 methods. The first is len. It returns how many items there are. The second is getItem. Given an index I, it returns one example. Here that is an image and its label. That is the whole contract. A dataset must be countable and indexable. GetItem hands back one item, not a batch. The batching is the DataLoader's job next. This is the dataset. 12 tiny images sit in a row. This is item 0 at the front. The last one is item 11. 12 items in all, in index order. Ask its length and you get 12. Index item 0 and you get one image. Its shape is 1 by 28 by 28 with label 0. Len of ds calls the len method. ds at 0 calls getItem. There is no batch dimension yet because this is one item. Second, the DataLoader. It wraps the dataset and hands out batches. Hand the dataset to a DataLoader. Set batch size to 4 and shuffle to true. Then loop over the loader. Each trip gives you one batch, xb and ib. Batch size 4 groups 4 items per batch. Shuffle true reorders the items each pass. You never index the loader by hand. It gives one batch at a time. With shuffle true, a sampler picks a fresh order. It does this before the items are grouped. Follow item 6. It is still item 6. It has just moved to the front. Each square is the same item as before. A new pass draws a new order. Shuffling matters for a reason. If the data were sorted by label, each batch would be lopsided. Shuffling mixes them, so no batch is all one kind. The loader cuts the shuffled order into groups of 4. This first batch holds 6, 5, 10, 9. The second batch holds 8, 1, 7, 2. The third batch holds 0, 3, 4, 11. Each batch is images of shape 4 by 1 by 28 by 28. The labels are shuffled, not 0 to 11 in order. Every item appears exactly once. Nothing is dropped, nothing repeats. Third, the batch dimension B stacking items is where it comes from. Look at one batch. 4 items of shape 1 by 28 by 28 are stacked. Together they become one tensor, 4 by 1 by 28 by 28. A single item is 1 by 28 by 28. Stack 4 of them and the loader adds a leading 4. That leading 4 is B, the batch dimension. It is the same B you pushed through the model. Add num workers 4. This spreads the fetching across 4 background processes. The workers fetch items while the model trains, so the loader keeps up with the model. This only changes the speed of loading. The batches, their contents, and their shapes stay the same. Loop over the loader. Each trip gives you one batch. Run the forward pass on the batch. Compute the loss against the labels. Then zero the grads, run backward and step the optimizer. These are the 5 steps you already know. Nothing about the loop changed. It now takes XB and IB from the loader. The same 5 steps run once for every batch. One full sweep over the loader is 1 epoch. And fourth, the last batch. What happens when the count does not divide evenly? Take 10 items with batch size 4. 10 does not divide by 4. With drop last false, you get 3 batches. Their sizes are 4, 4, and 2. With drop last true, you get 2 batches of 4. Drop last false is the default. It keeps the short final batch of 2. Drop last true throws that batch away. Then every batch is exactly full. Let's bring it together. A dataset is 2 methods. Len gives the count and getItem gives 1 item. A DataLoader wraps it. It shuffles the order when asked, and it hands out 1 batch per trip. Stacking batch size items adds a leading B 4 items of 1 by 28 by 28 become 4 by 1 by 28 by 28. The last batch can be short. It is dropped if drop last is true, and num workers only speeds up loading. One more check before we go. 10 items batch size 4 drop last false. How many batches and what sizes? Pause and predict. It is 3 batches, sizes 4, 4, and 2. 4 plus 4 is 8. The last 2 items form a short final batch. The trap is forgetting the remainder. You can feed the model batches now, but is it actually learning? The next lesson is validation, overfitting, and evaluation. A model that scores perfectly on the data it studied has told you nothing about new data. A held-out split gives the honest test. See you there.